Hi, today we are presenting the project Text Mining of Routers 21578 dataset by implementing Hadoop MapReduce on Amazon Web Server by Simone Saridi, Mary Vidya, Sisang, and Chen Sao. Motivation. Vast amount of news are being generated every day. By using parallel computing technique, the word counting and standardization processing time can be shortened. This application provides a new way of processing text-based data by allowing people to extract the most important relationships from huge amount of data. Text mining application examples. Social media such as Twitter and Facebook are used by organizations to uncover positive and negative trends. Through text mining, these trends can be identified and it can be used to leverage the positive trends and provide corrective action to counteract any negative comments. IBM's Watson computer combines text mining with predictive modeling and artificial intelligence techniques. Risk modeling use case. A large financial institution took separate data warehouses from multiple departments and combined them into a single global repository in Hadoop for the analysis. The bank used Hadoop cluster to construct a new and more accurate score of the risk in its customer portfolios. The more accurate score allowed the bank to manage its exposure good and to offer each customer better products and advice. Cybercrime prevention. The nature of the internet and communication features operated through it increase the risk of internet-based crimes. Text mining intelligence and anti-crime applications makes internet crime prevention easier for any enterprise and law enforcement or intelligence agencies. Trade surveillance use case. A large investment bank combines data about the parties that participate in a trade with the complex data that describes relationships among those parties and how they interact with one another. The combination allows the bank to recognize unusual trading activity and to flag it for human review. Healthcare and workers' compensation use case. This uses predictive modeling to detect claims, fraud, abuse, and errors before payment identifies suspicious providers as soon as aberrant behavior patterns emerge. Auto and PC insurance fraud use case. Fraud and risk segmentation is a very real challenge for insurance companies around the world. A typical use case is to use analytics to catch fraud early by leveraging data from incoming claims. Assess each claim against identified risk factors and segment claims into various risk categories, likely fraudulent claims to higher risk to low risk cases. Next is telecom use case. A large telco provider analyzed call logs and complex data from multiple sources. The use case calls for batch aggregation and analysis of web logs, network base station logs, and network signaling traffic for data mining and network route optimizations. The goal is to use the log data to build customer profiles, segment the customers, and optimize products and services accordingly.
Text mining is used to denote any system that analyzes large quantities of natural language text and detects lexical or linguistic usage patterns in an attempt to extract possible useful information. Finding chunks of interesting information from the natural language text is the purpose of text mining. With the advent of modernization, vast amounts of structured and unstructured data are being produced daily by a large number of business houses. Big data is difficult to work with and requires massively parallel software running on a large number of computers. One platform that provides this paradigm is Hadoop. Text mining is relatively a new area of computer science, and its use has grown as the unstructured data available continues to increase exponentially in both relevance and quantity. Techniques such as categorization, entity extraction, sentiment analysis, text mining extracts a useful information, knowledge hidden in text content. Some of the examples of text mining could be risk management, cybercrime, customer care services, spam filtering, and contextual advertising. Design. With an iterative approach, an organization can successfully use text analytics to gain insight into content-specific values such as sentiment, emotion, intensity, and relevance. Text and analytics technology is still considered to be an emerging technology. Text mining involves information retrieval. Match a user's query to documents in a collection of database. The first step is in text mining process is to find the body of documents that are relevant to the research questions. Natural language processing analyzes the text in structures based on human speech. It allows the computer to perform a grammatical analysis of a sentence to read the text. Information extraction involves structuring the data that the NLP system generates. Data mining, process of identifying patterns in large sets of data to find that new knowledge. So stage 1 of design, pre-processing text. Text documents can be represented as a cluster of words on which different text mining methods are based. To reduce the words from documents, special methods like filtering and stemming are applied. Stage 2, text mining technique applied. It is a vital stage in which a priori algorithm is applied on text in order to process the text. A priori algorithm for frequent item set mining and association rule over transactional databases. It proceeds by identifying the frequent individual items in the database and extending them to a larger and larger item sets, as long as those item sets appear sufficiently often in the database. The frequent item sets determined by a priori can be used to determine association rules which highlight general trends in the database. A priori uses a bottom-up approach where frequent subsets are extended one item at a time. The groups of candidates are tested against the data. The algorithm terminates when no further successful extensions are found. Stage 3, analysis of text. In this method, the outputs are analyzed for discovering the knowledge.
So firstly, we construct the master-slave nodes on the Amazon Web Server EC2 instance, and then, hold on. So firstly, we use the Java Eclipse as the SDK, and then we use Java version 1.8. And also we use Hadoop version 2.7.3, and also the Stanford Natural Language Processing API version 3.6.0. The input data will be the Reuters 21578 text categorization collection dataset. And the output should be the association rules calculated between each keywords. So firstly, we need to construct the nodes on the Amazon Web Server EC2 instance in master and slave fashion. And then we configure all the nodes, including installation of the required libraries such as Hadoop and Java. And then we format the name node. And then we upload the program, project.wc.jar. This jar file will include 3 main classes. First, separate all news. This takes .sgm files as input, and each SGM file will contain about thousands of articles. The output should be all the articles separate in the individual file. And then we use the a priori calculator. It took input as a list of keywords in each article. The output is all the association rules between the keywords. And finally, we have the PC project WC class. This is the main method of this program. It's read all the articles into a mapper class, and each mapper class will standardize each words and eliminate all the words from the stop word list, and then calculate the TF-IDF score for each word, and then pick out the top K score words. The K is a constant defined by the user. And last, it will call the a priori calculator to calculate all the association rules for the top K words. And last, we have the we need to execute the program and read the output. This is a flow chart of the whole process. So first, we input all the SGM files into separate all article.java, and then we get all the articles, input them into project WC, and we have the list of set of keywords from all articles, and we pass it into the a priori calculator, and we will finally have the association rules for each keyword.
So these two features show how runtime and the speed are changed when we change the number of CPU. Also, this is the screenshot of our program result. From this result, we can get information that bang may be not good according to the negative words showing, such as problem and weak. So we can find that speed up increases approximately linearly with number of CPU. Also, if the document is very small during the project, so the runtime will be limited to the job distribution speed. But if the problem set is large enough, then there will be significant speed up in text mining application. So the conclusion of the project, we can find that the use of MapReduce in Hadoop enhances handling of large corpora. Thus, MapReduce has proven to be a useful abstraction. Also, implementations like Hadoop deal with messy details like language and use case depend or different approach to facilitate Hadoop infrastructures. Also, during the project, not all association rules are crucial. So maybe we can design a filter in our future work to solve this problem. Thank you.